Reactions of ester. Ester cannot be converted into an acid chloride because it's less reactive than acid chloride, and one of the reasons is the Cl- is a weak base compared to OR-, and therefore this reaction is not possible under normal conditions. However, ester can be converted into carboxylic acid or amide, or they can be converted into another ester. Now, the first reaction that we are going to talk about is the hydrolysis reaction. When you say lysis, one compound is going to get converted into two or more compounds. An ester, when it is reacted with water, it is going to give us carboxylic acid and alcohol. Normally, this reaction is very slow, and therefore you need to have a catalyst for this reaction. So this reaction is called as hydrolysis. One ester can be converted into another ester through a trans-esterification reaction. For this, you will be taking a conjugate base that is different from the base that we have here in the original compound. So this is a methyl ester and you're reacting it with ethanol, right? In which case you're going to get a different ester. You're getting an ethyl ester and methanol, right? And this reaction is also slow, and therefore you also needed to have a catalyst for this. When esters reacts with amine to form amide, the reaction is called as aminolysis reaction. And even in this reaction, you will form two products. One is an amide and the other one is an alcohol. Luckily, this reaction is not slow and you do not need any catalyst. But if it's going to require a catalyst, then this reaction itself, it's not possible because the catalyst, which is an acid, is going to react with the amine base to form the salt, making the reaction not to occur. So now it has been converted into a salt. So the amine is not available as a nucleophile anymore. So the reaction will not happen. But you can increase the rate of this reaction by employing heat. Reactivity of esters. The reactivity of ester is going to depend on the leaving group present in the ester. For example, let's take phenyl acetate and methyl acetate. Here, the leaving group is phenolate ion, and here it's going to be the methoxide ion. Now, let's take the conjugate acids for each of these leaving group. The conjugate acid for the phenolate ion is phenol, which has a pK value of 10, and the conjugate acid of this methoxide ion is methanol, which has a pK value of 15.5. Now, between these two, we can definitely say that this is the strong acid. Right? A stronger acid should always give us a weaker base. So the conjugate base will be a weaker base, right? So this phenolate ion will be a weaker base. And why this is a weaker base? Because we can see that these electrons right here will be stabilized by resonance, right? And because of which this is going to act as a good leaving group. And because this is going to be a good leaving group, phenyl acetate will be more reactive compared to methyl acetate.